Alright, so we are going to be working on multiplying a constant, or multiplying a random variable by a constant. If you watch the other two videos on addition and subtraction, we already did that, so if you haven't, I would recommend doing that if you're not certain how those work. But for this one, we're going to multiply our x by -2. We are given that e of x is equal to 3, our expected value of x is 3, and our standard deviation of x is 4. So first we want to find the expected value of -2x. So a little visual here for you guys. Again, I'm going to draw a little distribution here. Our regular x is, or our x distribution is centered at 3. And there are 3 standard deviations that on each side that most of the distribution fall under. So 99.7% of the distribution of x is going to fall within 3 standard deviations of the mean, which means that most of this distribution is going to fall between -9 and 15. Now we're going to multiply x by -2. So -2x, we multiply every point by -2. So if we first take our center, which is at 3 here, 3, we multiply that by -2. And that means that our new center, our new expected value is going to be 3 times -2. Which just so happens to be -6 over here. So over here is -6, and that's our new, let me find a different color. That's our new expected value for -2x. So this is a center, and then we take our bottom end. So our lowest point is -9. Our lowest point, it's not technically the lowest point, but for us, the bottom part of our range is -9, and we multiply that by -2, we get 18. -9 times -2 is 18, which is going to be out here. So we'll just continue this line here, and we get 18 here. So our distribution range is all the way over there. And then we find our top point of our x distribution, which is 15. We multiply that by -2. 15 times -2 is going to be -30, which is way down here. I'm gonna just, I don't know if you can see that, so I'm gonna slide this over. Way off the side of the graph is -30 over here. And so we're gonna draw that in there. Might not be to scale, but you should see the point that I want you to see, which is that our standard deviation, or our spread of our distribution, is a lot wider. It's 2 times as wide, actually, as our original distribution. So we're going to take this step by step. So first of all, we talked already about what our new expected value is. So our expected value, or our center of our distribution of -2x, moved from 3, which is our original expected value. We times that by -2. And we found that it's centered now at -6. You guys can also pull that -2 out because the expected value of -2 is -2. So we say that the expected value of -2x is also equal to -2 times the expected value of x, which is just -6, or -2 if you want to plug these numbers in, -2 times 3. So again, you'll see now that our original distribution in blue ranged from -9 to 15, which is a range of 24. And now our second distribution in purple, our -2x distribution, our second distribution ranges from -30 to 18. So we look at that, our range now, if we figure it out, there's 30 between negative 30 and 0, and 18 from 0 to 18. We add those together, we find that our range is 48. So that means if you look at this, our first distribution of x was 24, our second distribution was 48. You'll notice that our purple distribution is now twice as wide, or twice as spread out, as our blue distribution. So this was x, and this is negative 2x in purple. So that's telling us that our standard deviation, which is another measure of spread, should probably also be times by 2. And you're wondering, maybe we multiplied x by negative 2, but why are we multiplying our standard deviation by positive 2? And we're doing that because our measures of spread are always positive. We can't have a negative measure of spread. So what we're really doing here is we're taking our original standard deviation, and we are going to multiply that, this little multiply sign, times the absolute value of whatever number is being plugged in. So if this was negative 4, we would do times negative 4 instead, the absolute value of negative 4 instead. So depending what number it is, you'll switch them around. But we do standard deviation of x times negative 2. The standard deviation, the standard deviation of x is just 4. The absolute value of negative 2 is just 2. And so we get that our standard deviation of negative 2x is 8 at the end. So the expected value follows basically what you would expect. We're going to multiply it by whatever x is getting multiplied by. And the same thing goes for our standard deviation, except we have to remember that our standard deviation has to be positive. So even if you forget to do an absolute value here, just remember that your standard deviation has to be positive, and you'll end up with the same answer that you would have gotten if you applied the absolute value earlier.